Okay, we're going to work on superposition, and we're going to show the relationship between how much work it takes to do that compared to mesh analysis, and how fast mesh analysis is compared to superposition. Um, Superposition is used for circuits that have more than one source, whether it's a current or voltage source, and mesh analysis is used in comparison to nodal analysis, which they're both used for circuits where you can't break the circuit down. And when I say break the circuit down, I mean if you have a bunch of resistors in series, you can add them all up to one value. So the total resistance is all those values added together. You can make one resistor for that circuit. All the resistors in parallel can be reduced to one resistor. So if you understand what I'm talking about, then I won't have to write all that down. If you don't know what I'm talking about, just ask me and I'll explain it to you. But this is the circuit we're going to work on. Well, this is V1. This is R1. This is R3. This is R2. And this is our V2. Okay. And superposition. DC sources get shorted, AC sources or current sources get opened. So let's solve for V. Let's use V1 circuit first, V1 source. So we rewrite number 1. And we're going to keep V1. And we're going to put a short where V2 was. Okay, so this is R1 without putting numbers down. Notice that R2 is in parallel with R3. Okay, we can say that R sub A is equal to R2 parallel with R3. And let's put values here because there are values. This is 54 volts. This is 48 volts. This is 4 ohms. This is 24 ohms. And this is 12 ohms. Now if we look, these two in parallel, it's product over sum. And if we do the product of these two, it's 48 ohms squared. And divide that by 16 ohms. We get 3 ohms. If we redrew the circuit and replace these parallel combination with one resistor, it would be a 3 ohm resistor. But that would be in series with R1, which means we got 27 ohms. Flowing through this entire, the 27 ohms of in total resistance just for the circuit with V1. Notice you got 27 ohms, you got 54 volts. So the total current would be V1 over R sub A, 54 volts over 27 ohms. That's 2 amps. 2 amps is going through RA. That is not the current that's flowing through both of these resistors right now without this source here. Okay, we got to use current divider formula here. unless we want to solve for the voltage first and then do all that. No, you just go straight to the current divider formula. So I want to figure out what the current through R3 is, because that's the current we're going to solve for. We're going to figure out what the total current flowing through R3 is, and the total voltage drop on it. We got to look at the parallel circuit to do the R sub A. We can say that the I sub R3 that's equal to I1 times R2 divided by RA. Well, R2 is 4 ohms and RA is 3 ohms. So 4 divided by 3 times 2, 8/3. So 8/3 amps. I'm just going to write it just like that. I could say it's the same as 3 goes into 8. 8 gets divided into 3. See here. 3 goes into 6 2 times, down 2.6. Probably 2.6. Okay, 2.6. No. It's not, it can't be 2.6. R sub 2 is 4 ohms. Oh, 4/3. 4/3 is roughly 1.2 or something like that. I1 is 2 amps. We're multiplying that by R sub 2 to get 8 divided by the R sub B. Oh no, it's the sum of these two. It would be the sum of these two, which would be 16. Here we're 16, which is 0.5 amps. It's not RA, it's R2 plus it's the sum of those two, R2 plus R3. It's not the thinking parallel circuit. No, current divider formula is different than parallel circuit. The parallel circuit's product over sum of the two. I was thinking R sub A, the total equation. Nah, that's just ridiculous. The current divider formula, I'm multiplying it by the opposite load that's in parallel to get the value of current that's flowing through this. But I got to add these two up on the bottom. So we get 0.5 amps. That's what's going through this element right here. And we can mark the polarity like so. Okay, now we got to do the same thing over here for V2. So we would have a circuit looking like this. Okay, this is R1, R2, R3. Notice R1 and R3 are in parallel. Well, if we do, let's say R sub B, that's going to be equal to R1 in parallel with R3, which is equal to R1 times R3. Well, 24 times 12. 24 times 2 is 48. 24 times 10 is 240. And 240 plus 48 is 288. So we get 288 ohms squared, and we're going to divide it by R1 plus the R3, which is 36 ohms. Now I'm pretty sure that's 8 ohms, because 36 and 36 is 72. If I add 72 to this number, I get 360, which is off by a factor of 10 from this. So this times 8 will give me 288. So our R sub B that's going to be 8 ohms. This is 4 ohms. We have our circuit. And that's V2. Okay, that's 48 volts. Now these are in series. We add these together. We get 12 ohms. 12 ohms, our I sub 2 is equal to 48 volts divided by 12 ohms. That's equal to 3 amps. No, 4 amps. Sorry, 4 amps. Okay, 4 amps. That's flowing through R2. So we have 4 amps here for sure. Well, we gotta subtract the other values. Let's not do that yet. We know we gotta do the current divider formula for this one. We know that I sub R B is equal to I2 times R1 over R1 plus R3. And that's going to be equal to 4 amps times R1, which is 24 ohms, divided by 36 over 24 over 36. That's actually equal to 1/3, or 2/3. So 8/3. An amp. 8/3 of an amp, an RB. And if we take 3 into 8, then we get 2, that's 6, 2 down, 6, 6, 18.66. Yeah, it's about 2.67 amps flowing through RB. Make sure I did that right. R1 is 24 ohms, so really it's 96 amps ohms divided by 96 divided by 36. So yeah, roughly 2.67. So that's the current that's flowing through there. Whenever we go back, you can take each of these currents that you know that are in the circuit and recombine them. For instance, we know that in this circuit, positive, negative, positive, negative. Positive, negative. We want to look at this on both sides. These currents are going to add up for this value. These currents will add up for the R2s. But these ones are an opposite polarity, so they will subtract. And we did it for RA, RB, the same resistor. If this one's 0.5 amps and this one's roughly 2.67, then we have roughly 2.1 amps flowing through this. But let's show you the mesh analysis so that you can see a different way of approaching this, a much more simpler way. All right, so let's redraw the circuit. All right, so this is V2, this is V1, R1, R3, R2. Always have the ground. volts, 24 ohms, 12 ohms, 4 ohms, and 48 volts. The way this works is we want to establish two currents. We'll do it in green. This is I1. This is I2. Okay. There's general approach. Which takes a longer time to do. But once you figure out general approach, you can go right to format approach. Okay. And so we're going to do what's called a KVL here, because we have voltages here, so we're going to do KVL. And KVL is the Greek symbol here, this Greek symbol for summation. The sum of the voltages in is equal to the sum of the voltages out. If you're going to do nodal analysis, it would be KCL, which is sum of the currents in equal to sum of the currents out. Both situations, you subtract this out version from both sides, and what you end up with is this. You get this minus this equal to 0. This subtracted from itself is 0, and this subtracted from this is this expression. And when we look at this expression, we want to say, okay, can we relate this equation to this loop? Yes, we can. We can start here and say negative value, by negative V1 plus a positive going this way, in this direction, I1, R1, plus a, and it'd be easier to write it this way, R3 times the parentheses of I1 minus I2. And that's all equal to 0, because when we come around here, we get back to this part. But now we're having a whole equation here. We have a negative value, we have a product, and we have, I can't remember what you call this, but it's a product of two different values here. Let's distribute this right here and move this to the other side. We end up with I1, R1, plus I1, R3, minus I2, R3, equal to the positive of this, which is V1. And we could still reduce this to make it more simplified, because we have two I1s here. We can say I1 times R1 plus R3, and let's get rid of that negative. We can say plus I2 times negative R3, and that's equal to V1. This right here is half the answer to the problem when they ask you to find the equations, the mesh equations. I could do the same thing for this side. Start here, go in this direction, positive here, negative here, positive here, negative here. Notice that I put positive up here on this side because that's in this loop. This one over here is down in this loop. I'm going from, current's always flowing from positive to negative. So I'm going from this positive to the negative. I'm heading towards that negative. So I'm going to put positive here, negative here, positive here, negative here. And when I do the equation, you'll end up with the same thing actually. The format approach is just like this. You just go straight to this. You say, okay, this whole loop, I1 times negative R3, because I1's in this loop. It's on the negative version of this R3. and we're going to add the I2 and plus these values, R2 plus R3. And that's equal to V2. Sometimes this might be negative, because if this were positive up here, and we started at the positive, and then plus this one equals 0, then this would be a negative. But we started negative just like we did this one. So it would be V2. So these are our two equations, okay? And I'm going to move this right up here. R1 plus R3. Okay. Doesn't matter if one's on the top, which one's on the top or on the bottom, doesn't matter. But what matters is that these are matrices now, okay? Our D, I1 is equal to D1 over D, and I2 is equal to D2 over D. Well, D is simply these values. D is equal to the matrices of negative R3, R1 plus R3, this is R2 plus R3, negative R3. You always have the opposite values on the different sides like that. It'll always turn out that way. It's symmetry. But now we're going to cross multiply and subtract from the other side. We're going to say this times this minus this times this. R1. Okay, this is our D. So let's figure what this is out. R3 is 12 ohms. We square that, we get 144. Negative times negative is positive, so 144 ohms squared. R2 plus R3 is 16 ohms. We're going to do minus 16 ohms times R1 plus R3 is 36. And we're going to do this over here. We'll do 36 times 16. That's 6, 3, 6, 12, 18, 21, 0. Oops, yeah, 6, 3. So 6, 7, 576. Make sure I did that right. 360 times 10 is 360. And then 360 times 36 times 5 is 180. 180 plus 360 is 540 plus another 36, 576. So this is 144 ohms squared minus 576 ohms squared. And then when we subtract this, we get a negative value. If this were up here, then it would be this value minus this. So it's actually going to be positive. I can't explain that part right now, but I know that it's either direction. You can do it either way. 432. So D is 432 ohms squared. Okay. And yeah, I might as well just make absolute value of that, because the answer is going to be the same no matter what we do. It's It's always going to be one value subtracted from the other. But when we do I1 or I2, we use the voltage values. So we want to solve for I1. And we'll flip this back the other way. We'll put this on top. This is the first, this is the second. So I1 we'll say is V1 negative R3, and then R1 or V2 here, then over here, well this is R2 plus R3, and this is negative R3. This is how we solve for I1. Same thing up here, over here. I2 would be equal to negative R3 here, R1 plus R3 here, and then we get V1, V2 over here. It's real simple. The product of these two, that's V1, negative V1 R3. And this is all going to be divided by D. Okay. I2, remember it's E1 divided by D. So this is just D. And then we have this D1, this is D2, and divided by D. D1 divided by D, D2 divided by D. So we get V1, negative V1 R3 minus, and I'll distribute this, V2 R2, actually, I won't distribute it, V2 R2 plus R3. So I'm going to add those values in. And that's going to be divided by D. This one, negative V2 R3 minus V1 times R1 plus R3. That's over D. Okay. So the negative V1, negative 54 volts times R3, that's a lot of math here. And I don't have my calculator with me. But I'm pretty sure if you put these numbers in, because here's D, if you were to solve for this, you would actually get I1 and I2. And if you subtract these two values, you'll get 2.17 amps flowing through here, like I did earlier. So let's just try to do that real quick. V1 is, let's write this out here, negative 54 volts times R3, which is, that's 12 ohms. And we're going to minus V2, which is 48 volts. And then we're going to add these two values, R2 and R3, which is 16 ohms. And we're going to divide that by 432 ohms squared. Notice that these ohms and volts and ohms is going to be added to volts and ohms. And then the volts and ohms divided by ohms squared leaves you with volts divided by ohms. And then you get volts divided by ohms is equal to amps. So this whole expression leaves you with an amperage. This is I1. So I could do this right here. Let's see, 54 times 12. 54 times 10 is 540. 54 and 54 is 108. So we're doing 540 plus 108. 648. I1, 648 volt ohms. And that's a negative value, by the way. And we're going to subtract that from, we'll do 488 times 10, that's 480. Half of 48 is 240. But if I multiply that by 5, it's 24. If I multiply it by 10, I get 240, which is, if I multiply this by 5, I get 240. So 240 and 480, 240, 720, and then 720 plus another 48. 768 minus 7 volt ohms divided by 4, 32 ohms squared. Well, these actually add together because they're both negative. 600 plus 600 is 1300. And then 60 and 40, that's 100. So 1416. And that's roughly, 432 and 432, that's 864. 864 and 432 is 1296. So this is roughly approximately 3. And let's see what we get here. Negative 48 volts times R3, which is 12 ohms, minus 54 volts times R1 plus R3, that's 36. So that one is going to be the biggest number we had a product of. 30, 32, 0, 12, 15, 16, 2, 9, 1. Okay. And 48 and 12, that's pretty simple. It's 96 plus 480, negative 576, minus 1924. Let's add 576 to that. 0, 9, 49, plus 2, 24.9. That's divided by 432. Now, if I multiply this by 5, I get 2,000. That's too much. Times 4. 432 times 4. 8, 2 down, 1 up, 16, 19, 28. And then add another 400. We get, so this is approximately equal to 5. Okay. And we're going to subtract this current from this current, and we're getting 2 amps. You can see, I'm not getting the actual number. If you do the calculator, you'll get the actual number probably. But this is actual mesh analysis. And yeah, there are more complicated problems. The most complicated problem is this one right here. That is the most complicated problem. You can't break it down to one element. There's 2 different sources in it, and you can't use superposition because superposition means you could break the elements down by shorting or opening the other source, depending on whether it's a DC source or current source, respectively. So that is the most complicated circuit. Hope y'all enjoyed.